All right, how's it going, geometry students? We are just going to go through a quick video today on your lesson, which section 4.2.2, and using the Pythagorean theorem to find side lengths of right triangles. So take a moment to pause this video to write down your objective. Okay, it won't take very long to get through because I know some of you have seen this before, but some of you haven't. So I'm just kind of going to treat it as though it's new, but not all that hard. But pretty important. This guy Pythagoras came up with something pretty awesome for us to find side lengths in right triangles. So again, pause your video and let's get going here when you're done writing it down. Okay, so now the Pythagorean theorem. Okay, Pythagoras, he figured out that in a right triangle, he did a lot of things, by the way. This famous theorem was just kind of one of the things he's noted for. But anyways, he figured out that if you have side lengths in a right triangle, the length of one of the legs, right? This is called a leg right here. This is called another leg, and then the longest side is called the hypotenuse. Perhaps you already know that. So the legs are the two sides that make up the right angle. The hypotenuse is the one that's opposite the right angle. Okay, he figured out that one of the legs squared plus the other leg squared, when you add those together, that equals the hypotenuse length squared. Okay, super important. The hypotenuse length, the longest leg goes here. These go here and here in any order, right? Like it doesn't matter what you call A and what you call B. The legs, either leg can be A or B, but the hypotenuse is C, and this will always work out. Now, proof, this is a theorem. Okay, proof I'm not going to do on this video. We're going to learn the proof of it later on in chapter 4. It's going to be something that you're actually going to have to know, but it's really not too hard. It's actually kind of fun to learn the proof of it, at least I think so. But moving on. So we're going to use this today to find side lengths. If we have two sides in a right triangle, we can find the third using the Pythagorean theorem. Okay, so if we have got to be a right triangle, let's say we know the hypotenuse is 7 and one of the legs is we'll call it 5. All right, and we're asked to find the other leg. Okay, so what we're going to want to do is, right, Pythagorean theorem, a squared plus b squared equals c squared. We're going to want to say 5 squared plus x squared equals 7 squared, or doesn't matter, x squared plus 5 squared equals 7 squared. Okay, either one of those is good and good. Here's what you do not want to do. This is bad. Don't do this. 5 squared plus 7 squared equals x squared. Wrong, because you just put the hypotenuse in one of the leg spots. So don't do that. Okay. Then it's a matter of just basically calculating this. All right. So x squared plus 25 equals 49. X squared plus 25 equals 49. X squared equals 24. Okay, and then when we go and square root both sides, x equals, the square root of 24 is like 4.9 something. I actually don't have a calculator right in front of me, but you can, I know it's just shy of 5 because the square root of 25 is 5. Or you write it as a simplified radical. The square root of 24 is actually written as 2 root 6 as a simplified radical. I'm not sure where your algebra skills were, in terms of last year going through the whole COVID, if you guys went through how to simplify radicals, but basically, that's, I'm not going to stress it too much. You can write it as a decimal. I'm way good with it. Okay, round it correctly, like 4.90. I honestly, I probably should grab a calculator here. Maybe I will. I'm going to hit pause real quick. Hold on. Okay, back found. Couldn't find a calculator, so we're using my phone, but it turns out it's 4.8989, blah, 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 blah. Okay, so rounding, either 4.9 or 4.90, if you round to the nearest hundredth. But don't write it as 4.8. That's not accurate, right? One of those two. Tenth or hundredth is probably good. Okay, let's do another one. Now, let's say we're not trying to find one of the legs, but let's say we're actually trying to find the hypotenuse. Okay, let's say this is 5 and this is 12. And if we're asking for this one, not drawn to scale, by the way, but Okay, now it would be 5 squared plus 12 squared equals x squared, right? Our hypotenuse is now x. Okay, that's 25 plus 144 equals x squared. 169 equals x squared. And then when we go and square root both sides, we actually get a whole number here, x equals 13. This brings me to my next point, right? 5, 12, 13. Notice they're all whole numbers, okay? This is what's called a Pythagorean triple, okay? There are other Pythagorean triples out here, but anytime we did not have that here, we had 5, 7, and then 2 root 6, or a decimal, 4.9, blah, blah, blah. Okay, if we have 3 whole numbers that create a right triangle, it's called a Pythagorean triple. So let's write this down. Pythagorean triple. Pythagorean triple, all right, 3 numbers that satisfy 3, I should say this, 3 whole numbers that create a right triangle. Okay, that satisfy the Pythagorean theorem. Okay, so probably the most basic one that most people know is 3, 4, 5. This creates a right triangle every single time. 3 squared plus 4 squared is equal to 5 squared, 9, 16, 25. So 3, 4, 5. Okay, that is considered a family of Pythagorean triples, and what's awesome is that actually any multiple of 3, 4, 5, so 6, 8, 10 is also 3 sides of a right triangle, and any multiple of this, right, 9, 12, 15, all the way down, like 30, 40, 50, okay, would also create a right triangle. And so we discovered a different family of Pythagorean triples, and it's 5, 12, 13, and any multiple of 5, 12, 13, 10, 24, 26 would also create a right triangle, etc., etc., etc. Okay, that's why I'm going to give you one more family here. Let me move this. Okay, another family I want you to know is 8, 15, and 17, and then any multiple of that is also right. There's I guess one more 7, the new family. Okay, if you really want a fourth family, 7, 24, 25, right? And every multiple of that. There's actually an infinite amount of families of Pythagorean triples too, which is pretty cool. So anyways, a couple things to show you there, because and why that's helpful is because when you get to a Pythagorean theorem problem and you recognize it, like if this is 6 and this is 10, don't even use Pythagorean theorem. Boom, that's going to be 8. You can recognize a Pythagorean triple. I mean, if you want to, you can look at this and be like, all right, you know, whoops, 6, 10. You can use a Pythagorean theorem, but I guarantee you, you're going to get 8 for this this other leg here, okay? And so if you can recognize them, they save you time. All right, now let's talk briefly about, like, you know, isosceles triangles and drawing like their heights and stuff, and maybe a word problem. We'll call it good. So let's draw an isosceles triangle. Let's call it 7. That's 7, and that maybe like 4 down here. Okay. Isosceles triangle. What is the height of this triangle? Okay, now how tall a triangle is neither one of these slanted lines, but rather a line that you would draw from the top down right to the base at a 90-degree angle. Whoops, at a 90-degree angle. Okay, this right here is the height. So if that's the height, what that's actually going to do in an isosceles triangle is it's going to break that bottom leg in half. So that's going to be 2, and that's going to be 2. So to find the height, you could draw this little mini right triangle off here. We just kind of peel it out from in there. The hypotenuse is 7. The bottom side is 2. And we want to know the height. Okay, that would be 2 squared plus h squared equals 7 squared. And we can find it just like that. 4 plus h squared equals 49. Okay, h squared equals 45. And h, when you square rooted this, would give us 3 times the square root of 5, right? Square root of 9 times the square root of 5 gives us square root of 45, and the square root of 9 is 3. So 3 root 5. Or if you don't remember how to simplify radicals or whatever, just write it as a decimal. Square root of 45 is like 6 point something. Let's find it. 45 square rooted 6.7. 6.7. How we would find that height, right? And why do we need height? Well, what do we want of the area of this thing? The area of this triangle would be the base, okay, which is 4 times the height, which is 6.7, divided by 2, right? 1/2 times base times height is the area of a triangle. We'll get into area a little bit more in a later chapter in geometry, but a lot of times we want to find heights of triangles, like that's important to us. So that's how you do it. Drop that height down, creates a right triangle. Okay. Lastly, let's do a word problem. Okay. You are standing 81 feet from a tree. The tree is 54 feet high. How far are you from the top of the tree? Okay. So in a word problem, obviously what we're missing is a picture. So draw a picture, right? Here's you. Here's you. Here's the tree. Okay, and then just kind of fill it in. This is 81. And then how tall something is always going to be a 90-degree angle, right? There's your 90-degree angle. That's 54, not drawn to scale. And we want to know how far are you from the very tip of that tree. Okay, so we draw a nice little picture, and then here's a better version of the triangle. Okay, 81, 54. Well, we have both the legs, and clearly we're trying to find the hypotenuse here. So 54 squared plus 81 squared equals c squared, or x squared, or whatever you want to call that variable. Right? And we go ahead and just calculate this. 54 times 54 is 2,916. 81 times 81 is 6,561. That's equal to c squared. Combine those. So 2,916 gives us 9,477 equals c squared. Square root both sides. Square root it, and we get 97.35 if we round that correctly. I'm going to round to the nearest hundredth. It's like 349. Okay, is equal to c. That's our distance, and we're in feet, by the way. Let's use our units now since it's a real-world problem. Okay, we use Pythagorean theorem quite often in like distance away from things, how high something is, and all that. So, okay. This should be a good enough video to help you guys out with your homework, which is posted, and I'll be back on Monday. Have a great weekend. Bye-bye.